3 or 4 problems. Each problem is a lengthy problem. I will try to give it. Problem number 16. According to the Thomas theory of liquid forces, the attractive force between the two nucleons inside a liquid is given by the potential. We know that the Leftover potential is V of R is equal to minus K by R e power minus R by A. K and A are positive constants. So, first one is we are supposed to compute find the law of force, that is force corresponding to this potential. This you can get by this formula, that is F is equal to minus del V by del R. So if you substitute and take the derivative of this, you will get minus K e power minus R by A, because you have to use product rule. First keep this, then take the derivative of this, that is minus 1 by R square. Then this, to keep it constant, take the derivative, you will get minus 1 by A. So if you calculate, you will get this answer. That is 1 by R square plus 1 by AR. Second one is construct Lagrangian for the system and write down the equation of motion for R. So the radial part of the equation of motion you have to write. So what is the Lagrangian kinetic energy minus potential energy? Kinetic energy is, this is the central force problem. Therefore, the kinetic energy is half mu R dot square plus dot square plus R square theta dot square minus this potential, that is minus K by R e power minus R by A. That is Lagrangian. Notice that Lagrangian is a function of R dot, theta dot. So this R is present, R dot is present, theta dot is present, theta is absent, therefore theta is a cyclic coordinate. So therefore the corresponding conjugate momentum, that is del L by del theta dot, is constant of motion. So that will get constant. This is mu R square theta dot. Now what is equation of motion, radial equation of motion for this Lagrangian? Since this is 2 degrees of freedom, for each degrees of freedom we have the equation of motion. We are going to consider only radial part of this equation of motion, that is d by dt of del L by del R dot minus del L by del R is equal to 0. So if you compute del L by del R dot, there is no R dot term here, so you will get mu R dot. If you take once again derivative with respect to time, mu R double dot will get minus del L by del R is from here you will get, and you will get it as del L by del R as mu R theta dot square minus K by R square e power minus R by A 1 plus R by A, that is equal to 0. This is the radial differential equation. Mu R double dot minus mu r theta dot square minus into minus plus k by r square e power minus r by a 1 plus r by a, that is equal to 0. Next question is, write down the condition for which the circular orbits are possible. The morning class are told for the circular orbit, the force is there, then f of r naught, that is r naught is the minimum of the potential, and from that we can compute. Alternately, he also mentioned the turning point, that is r dot is 0. Therefore, r dot is 0, r double dot is also 0. Therefore, r double dot is 0 is the condition to compute the circular orbit.
Will be r double dot or will be dou v dose? No, I think this is a time derivative.
Total time derivative.
Yeah, but for turning point on the graph, I think
R dot is 0. R dot is 0 for a turning point.
No, I'm wondering, this will be a time derivative. For turning point on the graph, it's a v versus r graph.
So
Should we not write dou v by dou r equal to 0?
R is equal to R naught. R double dot is equal to 0. That is the condition. Of course, R, okay, dot is also 0.
I understand. Acceleration. Okay.
Yeah. So therefore, this implies this term is 0. So you will get this term is 0. So other terms you can take. This term you can take that side. So k by r square, and r is equal to r naught e power minus r naught by a 1 plus r naught by a, that is equal to mu r naught theta dot square, and r is equal to r naught. So theta dot is equal to square root of, so if you simplify you will get it, k by mu 1 plus r naught by a e power minus r naught by 2a whole divided by r naught cross 3 by 2, because r naught cube is there, you take the square root, you will get r naught over 3 by 2. This means that the particle's initial angular velocity, that is theta, this theta dot is equal to the function depends on the r naught, that is starting radius. Fourth question is this: the particles moves in if the particle moves in a circle of radius r naught, determine total energy. So the subdivision is, we have to compute the total energy of this. That is, E is equal to, so to compute energy, let us now first compute the velocity, so the linear velocity of this particle. How to compute the linear velocity of the particle? See, if V be the, let V be the linear velocity of the particle of mass, I call mu, that is the reduced mass, around circle of radius r naught, then we know that mu v square by r naught is equal to minus f of centripetal.
Simply not use some r naught theta dot. Theta dot is what do you mean of this theta dot?
Theta dot is the initial
Like angle square.
yeah, in the speed.
So should we simply multiply this r naught and put v?
And this is proportion. This depends on the initial position. Initial r naught is the initial, right? So therefore,
What I thought was not probably get the same as I don't know. What I thought would get
see, there is
simply multiply this by, because we can use v equal to some r theta dot.
V is equal to
R theta dot. So we and circular motion. So this is
for circular motion. This is true.
So you get it.
Yeah, that is. I'm sorry. You can directly get from that. So from that, if you compute, you will get mu. If you substitute for f, you will get the same one. So you will get the answer. Velocity, you can compute velocity as 1 r naught plus, so that you can find. So this is equal to e power minus r naught by. So once if you compute velocity, you can compute the total energy. That is, total energy is half mu v square plus the potential at r is equal to r. So potential is given in that problem. So one can substitute that r is equal to r naught. We will get the answer as E is equal to 1 by 2 a e power minus r naught by a 1 by a minus 1 by r. So if you substitute, you will get this answer. The second one is the angular momentum. Angular momentum is the moment of linear momentum. Is the moment of linear momentum. Therefore, you can compute this r naught mu a vector. So if you compute the magnitude of this angular momentum, this is simply r naught mu v, and v is known to you, and you can substitute, get linear momentum, angular momentum. You get answer as k mu 1 plus r naught by a and e power minus r naught by 2a. The final is time period of circular motion. The time period is t is equal to 2 pi by omega. So you can write in terms of r naught by time period is equal to 2 pi r naught by, and this is v, velocity. So therefore this is equal to 2 pi r naught by the velocity is substitute here, and I will write out the final answer. 2 pi r naught e power r naught by 2a, and this is k by mu 1 by r naught plus 1 by a whole power minus 1 by 2. Minus 1 by 2. This is the time period in which this is argued. Finally, there is a question. This question: find a particle's trajectory in a bound orbit of Yukawa potential to first order in r by u. So what we have to do is
Find the sequence.
same thing what we have Sir has done. You saw that theta integral using this approximation.
The way I understand will be that exponential function as we expand.
Expander, and then keep the first order term. And so the orbit of a particle moving in the central force field, in this central force field, or central potential, theta of r is equal to some integral L by r square dr whole divided by square root of 2 mu e minus, and v is minus k by r e power minus r by 2. Therefore minus into minus plus 1 by k by r e power minus r by a minus the centrifugal term the first order means, as he said, it's approximately equal to 1 minus r. That's all. If you substitute, you will get an expression like this. Those steps are simple, therefore I am saying.
I thought we should go for another term because outside there's a K by R.
Right.
Because outside,
Yeah, that is combined.
I think you should go for another term because the R will be cancelled.
No, the question is, first order in order, so it is mentioned, otherwise you can try. It is mentioned in the question. This problem is already. So therefore this is theta of r that is equal to, so integral L by r square dr minus r gets cancelled 1 over a and then sorry k by a and then minus L square by 2 mu r square. So you combine these two, they are constant, so therefore one can combine this.
It's almost like shifting the zero level for potential.
Energy is, see energy is. This constant, energy is now shift the E minus K by A plus K by R minus L square by 2 mu R square. Square. So integration is similar one. So the orbit total energy only changes. So the orbit which implies the orbit of particle of total energy E minus K by A moving in potential like that is Coulomb potential. This is that approximation, this is similar to this. So therefore, identifying with the results what sir has mentioned in the morning class.
Instead of the E, you can put E minus E.
Yeah, E you shift, then so we know that by alpha by r is equal to 1 plus, that is eccentricity times cos theta. So this alpha is equal to L square by mu k and E is equal to square root of 1 plus 2 EL square by mu k square. So now the E is shifted. So now this E is E minus K by A times L square. The only difference is here, which implies, so as we know that for ellipse eccentricity is less than 1, the same thing once here, and E is equal to 0, this is circle. That's the one. Next question is,
Sorry to interrupt. It's a very philosophical question. This is all sub-nuclear, right? I was wondering, all subdivisions are classical questions, right? It's like this is sub-nuclear. I was wondering within the nucleus when you are not supposed to use all this, right? Classical physics not supposed to work.